Okay, so we're going to take a look at energy, just like Logan observed and the videos just showed. So this is one of those things that in science it has a very kind of specific definition. Obviously, like in everyday life, if we're talking about energy, we're like kind of, you think like, okay, how hyper are you? Like how much, motivation do you have to be moving around? Okay, usually when I think of energy, I think of somebody being hyper or being sleepy. Like that's what pops into my mind. But in science, energy, here's my mouse, is the ability to cause motion or to create change. Okay, cause motion or create change. And so that's a really broad definition. And so energy is something that can be transformed or transferred, but it is never lost or destroyed. And actually, this is something that we're talking about right now in physical science, that there is something called the law of conservation of energy, where the amount of energy in the universe is set, right? We're not gaining any more, we're not losing any, but all it does is transfer. And sometimes it transfers into a form that's less obvious, so we kind of feel like, hey, I think that disappeared or that's gone, when really it's just into a less useful or visible form of energy. So again, this unit, like the others, is going to be something that we talk about a lot next year as well. So don't just think, oh, we're learning it this year and it's done. Okay. There are two main categories. From the song and from the video, what are the two main types? Very good, kinetic and potential. So kinetic is the energy of moving, and in the video that we just watched, something has to be moving, right? That's what Tim said. He's like, if it's not moving, it's not kinetic energy. And the potential is either stored up energy or the energy that something has because of its positioning. And so you always, in the back of your mind with potential energy, you're going to have to be thinking, what is its kind of original or normal positioning? Like if nothing's being done to it, where would it be? How would it be behaving? Okay. So there are going to be, I believe it's 5 different types of potential energy. Notice the abbreviation PE, potential energy. We are going to look at gravitational potential energy, and we're going to actually shorten this even more and put GPE. So anytime you see GPE, it's gravitational potential energy. And then we're going to look at elastic potential energy, chemical potential energy, electrical. So with our non-contact forces, we already talked a lot about electrical and magnetic forces. And so now we're going to just kind of convert, actually gravitational, electrical, and magnetic were our non-contact. We're going to kind of look at them through the potential energy lens now. So everything that you already learned in that first unit is still going to kind of apply. We're just going to have a little bit of a different focus now. And you guys did really good with that unit, so this should be pretty good, I think. So we're going to start with gravitational potential energy, or GPE. And so the video showed some examples, obviously the mason jars that he kept breaking as he dropped them. But the type of potential energy that something has because of its vertical position. And it has to be compared to a frame of reference. Typically that's going to be the ground, but in some situations maybe it's the countertop or a tabletop. It could be something different. Obviously, you have to know what that is before you can kind of measure the height or kind of look at what's involved. So always be kind of aware of what that frame of reference or that focus, that starting point should be. And obviously height is going to be one of the variables because we're talking about vertical positioning. Anybody remember from the video what the other one was? It was the height, and then what else about the object? You were really watching. Nice. Very good. The mass. So it is the height above the reference point. Again, totally makes sense. Very logical because this is talking about vertical positioning and allowing gravity to pull on an object. And then the mass of the object. So kind of like inertia, right? The more mass something has, the more you see the effects of inertia. Same kind of thing here. The larger the mass, the more gravitational potential energy something has. And so if you change either of those variables, then you are getting a change in gravitational potential energy. And next year we'll actually calculate the GPE. This year we won't calculate it, but it's pretty simple. It's just mass times gravity times height. But we will add in the equation for that next year. Okay, so slide number 5. A common abbreviation is GPE, which I've already mentioned, but to have it in writing. And so the first thing you need to do is identify what the frame of reference is. Where's your starting point? Kind of like, what are you comparing the height to? So here's the elephant up on its little stand. And so obviously the ground is the frame of reference, or the reference point. Same thing with the basketball, right? It makes sense that it's the ground that is going to be your frame of reference. And like I said, typically it is the ground, but you just have to kind of be aware of that. So if we're, can't remember if there's another, yeah. And in most cases it will be the ground. So let's take a look at this example real quick. So you have position A, B, C is almost to the ground, but not quite, and then D is right here. So C is almost to the ground, D is here. So is the mass of that basketball changing? Is that going to be the variable that's going to affect the GPE then? Seeing some no's. All right, so all we have to do is look at height. So where does this basketball, position A, B, C, or D, where does it have the most gravitational potential energy, do you think? What do you think, Andrew?
B.
Why?
Is this the highest fellow?
Good. B, the highest. Where is it going to have the least amount of GPE, Addie? Okay, because it's at the lowest. Very good. That's all you're really looking at, the highest and lowest. Okay, and then everything in between. So if we put these in order, if we go B, what's the next highest? What do you think, Corbin? So B to A, and then D, because Addie said C is our lowest. Okay, that's all it is. Nothing too tricky. All right, so if we're looking at these two children playing on the slide, so here we have, it's kind of hard to tell by the haircuts, but I think that this is supposed to be the girl. And here we have the boy. They look like they're pretty close to the same size, so probably should have about the same mass. Which one do you think then would have the greatest GPE? What do you think, Ronan? The one at the top or the one at the bottom?
Top.
Okay. And we're calling that the girl. And so obviously, even if the bottom of the slide was the reference point or if the ground was, she definitely has the most. Now, if there was somebody standing on the ground and we were comparing all three of them, then we would have to decide, okay, is the ground the reference point or is the bottom of the slide? But since you're both on the slide, it really wouldn't matter. Okay, she has more height. The boy has less because he's closer to the ground or the bottom of the slide. So in both of these examples so far, we've looked at the mass being the same or similar, right? We don't know the exact numbers on their masses. So really, we've just been comparing height. She has more height at the top, he has less height at the bottom. And again, very simple concept, which you guys seem to get. All right, now let's take a look if the mass changes as well. So here we have object A, B, and C, and there's like a little key. The yellow balls have 50 kilogram mass, the blue is 25 kilograms. So if I'm looking at the ground, I'm assuming that's my frame of reference. So based on objects A and C, which one has the greatest GPE? What do you think, Izzy?
C.
Right, why?
Because it's the highest.
Okay, now if I'm comparing objects C and B, which one is going to have the greater GPE? Henry?
C.
Why?
And more mass.
Okay, so they have equal height, but it has greater mass. Now if I compared A to B, this is where we'd actually probably need to calculate it, because B has a smaller mass, half the mass, but 2 times the height. Like the height is doubled, but the mass is cut in half. Here the mass is doubled, but the height is cut in half. So they might be equal, but we would need firm numbers on the height, and we could actually calculate it. But you would think these would be pretty close to having the same GPE, because smaller mass but greater height, bigger mass but lower height, right? So you could make a pretty good argument that they'd be similar, but you couldn't say for sure without calculating it. But you could say for sure between A and C that C is greater, and you could say between B and C that C is greater. Okay, so C is going to have the most. Again, the greatest height and mass. And this time you couldn't just say height, because B has the same height, so you'd have to include the mass in that one. Okay, so we're going to go ahead and stop there. Yeah, make sure there wasn't another one. We have a video and then another song. Sometimes these ones don't.
Now, what is potential energy? Let me give you an example. This is a 32. Well, anytime that you're moving this around, especially when you're resisting gravity, you're doing work. You're using energy to move it around. Right now, I'm applying as much force as there is gravity. If I lift it up higher, I'm applying more. And if I happen to take this weight and set it up here, well, I'm not doing any work. But the energy doesn't go away. Energy can't be destroyed or created. It can only be transferred or stored or changed from one thing to another. This now has energy. You may not, it's not glowing or anything like that, you know. You think that if it has energy, well, not really. It's fun anyway. So I put this up here and I've given it potential energy. So how much potential energy does it have? There's an equation for that. It's gravitational potential energy equals mass, well, 30 pounds, we'll convert that to kilograms, times the gravitational constant, which is how much acceleration gravity applies, 9.8 meters per second squared, and then the distance in meters from here to the Earth's surface, the floor, and then you have how much energy in joules this actually has been stored with. You stored energy in it, just like if you compress a spring, pull back a bow, move something, you've now stored energy in this, and that's its potential energy. So we're going to give you a demonstration of how much energy this has. We'll find out in a second. Because I have a willing volunteer down here who has graciously accepted to be the recipient of all this potential energy. Okay, so let's see how much potential energy this has. Well, that's pretty good. I like that. That was fun. Well, you know, I broke a brick. That was fun. But I keep thinking, I'm just missing that little extra special something. I think I know what. Let's do something about that, shall we? Sorry.
He gets the Yeah. So good examples, but he does get a little wild. I mean, at least you guys are paying attention. All right, here is another song.
Not this dude.
It's pretty catchy too.
Exists in many forms, never created or destroyed. Energy, it can't be created. Energy, it can't be destroyed. Energy, it can't be created. Energy, it can't be destroyed. Two main types of energy. Potential and kinetic energy. Potential is energy that's stored. Kinetic is motion energy. Energy, it can't be created. Energy, it can't be destroyed. Energy, it can't be created. Energy, it can't be destroyed. Some of the forms of potential energy: gravitational, chemical, nuclear, and elastic. And some forms of kinetic energy: electrical, mechanical, heat, and light. Energy, it can't be created. Energy, it can't be destroyed. Energy, it can't be created. Energy, it can't be destroyed.
She like pedicures or whatever. She like brown eyes like baby.
Chloe, you're supposed to remind me.